Okay, now we move to example number 10, and example number 9 is left for you as an exercise. It is very similar to example number 10. So example number 10 says, find the area of the region shared by the circles r equals cosine theta and r equals sine theta. So we want to find the area that is shared between or by those two circles. Okay, so we want to find the area common between those two circles, which is this shaded area. Do you agree? Now this shaded area is the only area common between those two circles. Let me start by finding the point of intersection. So, it is clear that the origin is point of intersection, and we got this point as well. So to find this point of intersection, we equate those two circles together. So cosine theta equals sine theta. Okay? Now, if you divide both sides by cosine theta, then what do we get? Tan theta equals 1, and we are in the first quadrant, so it means that theta equals pi over 4. Okay, so this point is pi over 4, which means that this line over here is theta equals pi over 4. Okay, pi over 4. Now, note that the shaded area that we want to find can be divided into two parts again. So look at this area, this blue one, okay, this blue one, and the other area, the other part is the red area, the red one. Okay, now we can find the blue area and then find the red area. If we add them, then we get the area common between those two circles. Okay, so A equals, again, if I call the blue one A1 and the red one A2, then the whole shaded area, shared or common between the two circles, equals A1 plus A2. Now, A equals, what is A1? Notice that A1 is the area under which curve? Okay, it is the area under this circle, r equals sine theta. I'm going to explain in a minute why. So it is half integration. Now, the blue region, theta for the blue region runs from 0 into pi over 4. So 0 into pi over 4. Off or under the polar curve, r equals sine theta, so we get r squared, so sine squared theta d theta. Okay, so this is A1. Again, why did I choose sine theta? Because suppose that I choose cosine theta. What is the area enclosed by cosine theta from 0 to pi over 4? Remember that this is cosine theta. So if I choose cosine theta from 0 to pi over 4, then I will get this whole area. Do you agree? Because this is cosine. This is r equals cosine theta. So from 0 to pi over 4, all this area will be calculated, which is not the area I want. I just want the blue region, okay, the area common between those two circles. But if I choose sine theta from 0 to pi over 4, I will only calculate this area, which is the blue one. Because remember that this is the circle r equals sine theta. Okay? Now similarly, plus A2. What is A2? Now I guess it's easy for you to determine A2. It is half integration from pi over 4 into pi over 2. Okay? Pi over 4, this line, to pi over 2, this line. So if theta goes from pi over 2, from pi over 4 to pi over 2, you're gonna sweep out this red region. But it is under which curve? It is under cosine, so we get r squared cosine squared theta d theta. Again, why did I choose cosine theta? Because if I choose sine theta over here, from pi over 4 to pi over 2, pi over 4, this is pi over 4, and this is pi over 2. If I choose the area enclosed by sine theta, then I will calculate this whole area, okay, which is not needed. It is more than what we need. Okay, so this is the setup for the integral. Now I guess you can continue integrating, to find the desired area.